Okay, let me just get into it. So, I'm going to talk about very much, it's around sort of keeping pace with developments, keeping pace with change, keeping pace with sort of the problem, which is cybersecurity primarily. So I'm not going to talk too much about auditors or make funny jokes about individual people, but a little bit about myself. We covered that already, so I'll skip on very much. It's very much around, with some organizations, they may have hundreds or thousands of endpoints. And in effect, each endpoint will have, a service endpoint being an IP or an API, depending on what layer you're looking at. And it's very much around if you've many endpoints, you have many services behind those. Those services are being built, by developers or by outsourced development. And it's very much around, so how do we keep track of this type of stuff, right? So it's like the idea of keeping the wolf from the door, but if you have maybe 1,000 or 1,000,000 doors, how do we do that as well? Something that's pretty important in order to, and it does relate to Javed's talk around asset identification, attack surface visibility is a pretty important part of security, and it has been somewhat underrated, I think, up until the last few years. So very much around the reason we're talking about this, the reason I'm talking about this is very much around what we do in EdgeScan is we provide continuous testing, continuous vulnerability management, continuous asset profiling for our clients. So we process probably thousands of vulnerabilities every month, for our clients. What's funny is I've been doing this, sort of security stuff, for maybe nearly 20 years, and we're still having the same problems, right? We're still having the same vulnerabilities. Some of the most common vulnerabilities are getting into their 30th birthday. They're pretty old. Some of them, the phrases were coined in the days of Netscape Navigator, and that's how old these issues are. So it's very much around the fact that these vulnerabilities manifest themselves across many areas of our stack. So I think one of the things that we've been doing wrong as an industry, for example, is we've siloed. If you look at sort of these industry analysts, they've siloed vulnerability management as being sort of network, and your web application security, or AST, application security testing, is sort of another silo. And in our experience, the idea of if you're a determined attacker or, a curious person, it doesn't really matter. If you find a vulnerability in the system, it could be in the web layer 7 of the stack, or it could be, a protocol or port or sort of an insecure system or anything in between. And very much, something we need to look at is look at systems as assets and look at assets as a full stack, sort of, a monolith in some ways, which continually change. All of these layers, in effect, can change all the time. Be they, patching, be they new services being deployed, be they, anything from, new code being deployed, et cetera. One of the problems, our challenges we have is very much that, we're deploying much more quicker, and we're writing code more quicker. We're pushing code on a daily basis, unlike the traditional sort of waterfall method, which I grew up with when I was a developer in my youth. So, here's an example of last month's vulnerabilities. The point I'm trying to make here, some of these vulnerabilities are quite old. We all know about them. We've seen them before. And in effect, we're still finding tons and tons of this stuff all the time. So this is sort of some stats from October, and you can see things like cross-site scripting, external service interaction, and something that's pretty disappointing is unpatched, sort of unsupported, frameworks. So, you can't, there was a mention of Equifax in the last talk, and the idea around, okay, these guys at a certain point, they didn't know they needed to patch their struts, stack, and they didn't do it, and then they got hacked, and it was really bad. And there was a patch available for it. But in some cases, organizations don't even know that they need to patch stuff. They don't even know, what's out there. They have no clue of what their sort of attack profile is, what their attack surface is, what's facing the internet, what doors are facing the internet, and how are we locking those doors and keeping them secure. So, one of the things what we need to sort of, be better at as an industry, the idea of a one-off pen test works, for that point in time. It's a sort of a snapshot in time. But the idea would be is that the day after the report is delivered, in the traditional pen testing sense, the system's changed already. There's new code has been deployed, and various systems have been spun up or torn down, because we're always in sort of an era of rapid change. So some of the stuff, every year we do this thing called the Vulnerability Stats Report. We're just starting to write the 2019 one now. So these stats are from January, of this year. So they're a little bit out of date, but they probably won't change too much. In effect, the idea would be we're looking at sort of the application layer as one piece, and then we have the sort of the non-application layer as another piece. And you can see, bottom line is we're still in 2018, we're still seeing about 20% of vulnerabilities discovered are still higher critical risk issues. And again, some of that is due to the fact that we're pushing, we're pushing code very, very frequently, or we don't even know we have that vulnerability, because you'll see even from the Verizon DBI or otherwise even from our own stats report that some of the most common vulnerabilities we're finding are actually old CVEs, they're old patches. One of the most common vulnerabilities we found in 2018 is in effect it's a CVE from 2009. So it's not like it's 0-day attack or some super advanced hack. Most hacks, most news grabbing attacks on companies are pretty simple. The idea would be it's very much if you can get access to something, you can in effect alter the code, like the Mage card stuff, which happened to one of the airlines in the UK recently, and it's happened to some ticketing companies as well. And the idea will be there is in effect is that they in effect rewrote the JavaScript to redirect submission forms, and in effect harvesting people's vulnerability, harvesting people's credit card data, CVV codes, and so on and so forth. So in effect, we're still finding this type of stuff, and I think this is sort of somewhat of a legacy, and I'd like to see it improve. And I think things like bug bounties and things like continuous asset profiling and things like continuous sort of vulnerability management with some intelligence can probably change the dial a little bit, because the stats have been sort of very much static in terms of things are still crap, and they have been for a long, long time. Again, with the infrastructure layer, it's a similar story. What we see though is we have less critical and high risks, as you can see. And the reason for that is, I think, is because it's commoditized. Servers are commoditized. The idea that there's only so many flavors of a server. There's only so many moving parts in sort of a piece of infrastructure. And therefore we sort of have got a handle to some degree on how to fix this stuff, assuming that we're doing the patching and whatnot. But in effect, if you look at the stats, the idea will be is that we're actually finding more vulnerabilities on the infrastructure layer, but the majority of the high and critical risks are on the application layer. So the application layer is a much higher risk density. As in, we're finding maybe fewer vulnerabilities, but a lot of them are really, really bad things. So, in effect, if we're in a world of constant flux, if we're in a world, in effect, where we have cloud, we're tearing up, we're spinning up stuff and we're tearing down things, we have code being deployed on a very frequent basis. We have lots of movement, so even if you stay still, right, even if you don't change your code, today you're secure, tomorrow some vulnerability is discovered in your stack and all of a sudden you're vulnerable, but you didn't actually change anything at all, right? So it's sort of it's a moving target in terms of the goalposts keep moving, but also the ground beneath you keeps moving as well. And what the challenge is, in effect, it's in effect change. And as I said, we're in an era of constant change and constant deployment, and change gives rise to risk, and risk in effect give rise to a breach, and so on and so forth. So what we need to do is try and keep pace with development. It's a really important thing that we keep pace, things like DevSecOps, and so on and so forth, to try and, in effect, keep pace keep pace with two things. Keep pace with, in effect, with the amount of patching and the amount of vulnerabilities we're finding on a daily basis, but also to be able to keep pace in effect, people deploying new services, new code, APIs, new versions, mobile version, and so on and so forth. And why is this? Well, it's still from the Verizon DBIR, which is a data breach incident report, which came out, again, early in 18. The 19 one is now, obviously. It's very much that the high proportion of breaches, involved hacking and a high proportion of breaches, in effect, were perpetrated by outsiders. So there is this idea of insider risk and insider attacks, and we've things like lots of systems like we've DLP and various types of monitoring, and I think the industry's grown. I'm not sure if all these shiny boxes that people buy actually will fix anything, but in effect, we're still seeing quite a high amount of targeted and opportunistic attacks from the external side, and a lot of this has been sort of attributed to in effect what we would call as hacking. So continuous security. It's sort of the idea around there's been a big drive over the last few years around DevOps and DevSecOps. And the idea with DevSecOps is that security is an end-to-end cultural phenomena. It's in effect that we have pipelines of code pushing through your system development lifecycle. Code's committed on one end, it comes out the other end as production code, and in effect, what we're doing is we're using a lot of tooling, and we're trying to keep the flow of code continuously fast, right? We're trying to keep the flow, so we're not trying to stop. Like, the idea of a penetration test in a DevSecOps pipeline doesn't really work at all, right? Because it's slow, it's a choke point. So what we want to do is use tooling, we want to have tuned tooling, and in effect, we want to sort of, try and enable developers to produce more stuff, because bottom line is it's the products and services that your companies, in effect, it's products and services, in fact, that your companies sell and make are the things which actually keep you in a job as a security practitioner. Okay. So the idea again is when we're getting to this, the continuous integration, the continuous deployment model is rather than we're sort of spread betting. What we're doing is we have a potential to find vulnerabilities on a more frequent basis, right? The idea is that we have so rather than have all our bets placed on the end result in a waterfall cycle, we're actually going to, sort of have many iterations. And that's the way code has been developed. And that's sort of the way where, we have to, adopt to be security, practitioners and in order to enable people to build code in this way and build systems in this way. So, this is from the OWASP. There's a sort of a decent OWASP project around the rugged DevOps. And again, I'm not going to dwell too much on this, but the idea was we have a pipeline. And the pipeline, we have things like continuous. Everything's continuous. We have security tools. We have, as part of our build system, as part of our builds, sort of when we actually, in terms of continuous integration, we check code in, it gets built automatically. And as part of that, then these tools would be invoked. And in fact, these tools then would be used to detect vulnerabilities. But there are some caveats there, and I'm not sure there's $1 million question around that. And it's in fact the idea of what I would call as anti-scale. Its automation is really good for finding things like cross-site scripting or SQL injection or injection attacks or bad input validation or, bad session management, in terms of SAST, which is static analysis, and in DAST, which is like dynamic runtime testing. And both of them combined are very, very powerful. But automation doesn't understand risk context. It doesn't understand business logic. It doesn't understand sort of, things like that. So therefore, these tools can produce a lot of data. And in effect, what we want is information. And what we want to do is reduce white noise. And we want to fix the things that matter, because not all vulnerabilities are created equal, right? Sort of alluding again to Java's talk, auditors want you to fix everything. And in effect, no, what we want to do as security people is protect our companies and our businesses we work for, right? Or our clients. So the idea around automation on its own is problematic. And it's sort of like the elephant in the room, right? The idea will be these tools that find this stuff, and either they're not finding certain things like business logic and intelligent sort of hacks in terms of twisting and bending logic, or they're producing a lot of false positives, right? Which can be remediated to a certain degree, but it's still quite challenging. So all of those things, what I would call, is in effect choke points. So, the idea will be is to have lots and lots of tools. Give me loads of tools. We'll point them all there. Half of them you won't use. You just buy them. The other half you'll scan. They'll produce lots and lots of data. You'll get 300-page reports. And in effect, then you've some poor sod, which in effect has to, go through all those issues and try and figure out what's real and what isn't. The last thing we want to do in a DevSec, sort of a continuous integration environment is give, how would you say, is give developers false positives, is to tell developers their code is broken or their baby is ugly, and in fact it isn't. And the reason being is security has to integrate, culturally with development and enable development to build more secure code, as opposed to just telling developers and sysadmins, etc., that you're doing this wrong and fix it, which is not going to work. And that's something we may have been guilty of over years, but I think it's something that we have to address. So continuous visibility then. We need continuous visibility in effect to keep abreast of what's going on, right? Because we're continuously changing. So from a production environment, you could have things like protocol port. It's continuous asset profiling. At any point in time, you may see, what have I got live, facing the internet or maybe some B2B systems. What APIs do I have live, etc. And in doing this over time, you start to get metrics about what's being deployed insecurely. You can generate alerts. You can in effect find what's going on at any point in time. And also, as a virtue of doing this on a continuous basis, you might wind up with sort of a bill of materials, or an asset registry. What do I have, facing the internet, which is a hard question to answer. Like, a lot of companies, literally, even some companies with lots of brains and lots of money, there's no shortage of any of that stuff. They actually don't even know what they have, or what they have to secure. So if you can't even start on the path of improving security if you don't know, if you can't measure. So the idea, the old saying is you can't improve what you can't measure, and continuous visibility is very much a part of that. Right. So, things like, when companies have a range, so the idea will be, they have an IP range rather than, individual IPs, be able to sort of have visibility of the entire range. So if something gets deployed without permission, it breaks change control rules, things like that. Also things like if we do find a new system that's live, which wasn't there yesterday, automatically, the idea is consider automatically assessing it and testing it, generating alerts, informing people a new system's been found, a new protocol, or a port has been opened, etc. And then, that goes into the idea around, well, if we are continuously, continuously discovering, continuously profiling, then we start to catch things like CVEs or patching issues, configuration issues, and so on and so forth. Now, the challenge is, in my view, as an industry, is we can do this with automation. I think it's fabulous, but what we do have a challenge with right now is the idea of logical and business level vulnerabilities. So this is the idea of, say, doing a foreign exchange application, and midway through the transaction, you change the denomination of the currency and you sort of make some money or something like that. So automation really doesn't do that very well at this point. Okay. So again, it's around looking at automatic discovery, automatic detection of new hosts, automatic assessment. So if we find a new host, a new application, a new server at any point in time on our estate, it automatically at least gets some level of security. And then also like being able to alert, so, hey, we found a new API on one of your boxes, which wasn't there yesterday or 4 hours ago or something like that. And in effect, we need to sort of, obviously be aware of that. And then what do we do when we do find something like that? It could be legitimate, but maybe security wasn't aware of that. Okay. So using automation alone is the way I'd say it. It's white noise generation. It doesn't give you value. It produces data and not information. So we need to, the idea is scale and accuracy are the challenges that we have. All right. So what I'm talking about there is some sort of some ideas around that. So the idea of alerts on change, so delta analysis. If we see change, make an alert of it. If we see something changing at all, be it change in a firewall rule, be it a change in the web application or anything else, we need to alert. At least somebody will know that there's something's changed or something's happened. And as I said, alluded to before, change is what in effect produces additional risk or may introduce additional risk. And we need to sort of, and we get into the idea then of vulnerability intelligence and sort of maybe a clearer view of where we are. Okay. So this is sort of an example of this. So vulnerability intelligence can sort of be the idea where if we don't find a vulnerability on a particular cycle of assessment, and then on the subsequent cycle of assessment, you find an issue, well then in effect that's a delta. Let's send an alert to somebody. Let's raise a JIRA ticket. Let's do something to say, hey, there's something's changed here. Do we need to do anything about it? Also then, if a vulnerability or something was closed, right? Again, it could be the idea around, that again is change, right? And in effect, the management of that is important as well. So what we start to do is over time, because we have multiple cycles of testing, is we start to get a profile. We start running out of time here. All right. We start to get a profile of an application. And if we have a profile of an application or of an asset, in effect, that your organization owns, and maybe it's critical, the idea will be with that profiling, in effect, then, you're in a lot better position, from the point of view of making sure that your stuff is secure, right? And the reason we need to do this across the stack is because, in effect, ladies and gentlemen, like hackers don't give a shit. Hackers don't care where your vulnerability is. They'll come in, they'll find a vulnerability, they'll try and exploit it. As I said, I think a lot of industry analysts are guilty of siloing vulnerability management and web app security, and I think they should be all ran together as sort of a one glass of pain. And in effect, the idea will be, hackers don't care if you've passed your audit. Hackers don't care if we couldn't test this application because, we weren't allowed because it was too critical or whatever else. So the idea is to try and have some full stack view of all your assets on a continuous basis. And that's sort of the challenge. A couple of last few points around pitfalls of all this automation. Vulnerabilities sometimes only needed to be treated as a singleton, because the idea would be is that not all vulnerability statistics are not linear, right? They're very much a non-linear concept. Risk is very much a non-linear concept. So the idea of having a high volume of low risk issues that you find, and if you're just recording them as metrics, it will skew your metrics. Your metrics won't work, because what you wind up with is, in effect, is that you have a million low-risk metrics and one critical risk metric, and you give them scores like CVSS scores or something like that. But the idea is that from a metric point of view, all of the low risk combined is more of an issue to fix than the critical issue. But so it doesn't really work that way. So the idea is when you want to do metrics and when you want to sort of measure stuff, you need to consider risk as well, which is, again, it's a non-linear problem. Okay. Finally, just to conclude for now, in effect, full stack security is something that I think should be considered, rather than just getting a pen test on an app or a server. Combining the risk profile is very important. Automation is great. Don't get me wrong. DevSecOps is brilliant. I love it. But the thing is that you need to understand that the pitfalls of DevSecOps, what they are. And it can be, I give you a false sense of security, and the idea of automation in the pipeline, it will catch all the low-hanging fruit, and hopefully that feedback loop will empower developers not to repeat the same mistake. But in terms of logical issues and business-related stuff, which automation simply doesn't understand what it's testing anyway. There is a bit of an elephant in the room from that point of view. And that's all I have time for. Apologies for running over. Okay, good. Thanks.